Let's see what an arithmetic progression is. An arithmetic progression is nothing but a sequence of numbers, let's say A1, A2, A3, and so on, with a common difference between them. Like between the numbers next to each other, there is a common difference which we can denote by D. Now let's say I want to find the nth term of this arithmetic sequence. So the nth term is given by A1 plus n minus 1 times D. Now what is A1? A1 is the first term, n is the nth term that I need, and D is the common difference. Let's look at it through an example. Let's say we have a series which is 3, then 7, 11 and 15. Suppose I want the third term of the series. We already know it's 11, but let's say I want to find out the third term of the series. Then I take this formula here. A1, which is the first term, plus the third term, so n becomes 3, minus 1 times D, the common difference is 4 between the terms. So this gives 3 plus 2 times 4, which is 11, which is same as this. Now let's say we have an arithmetic series. A series is nothing but a sum of the terms in the sequence, like A1 plus A2 plus A3 and so on. Then I want to find the sum of the terms in a series. So let's say I want to find the sum of all the terms in this particular series. And let's make the series finite. For example, I have finite number of terms, A1 plus A2 plus A3 plus A4. It can be A5, 5 terms or 6 terms, and we can generalize it as AN, a finite series with up to n numbers. And I want to find the sum of those numbers in the series denoted by Sn. How can we do that? Let's say the sum is, we have to add all the terms simply because it's A1 plus D is A2, because the difference between A1 and A2 is D. So when I add D to A1, we get A2. And similarly, we keep doing that till the last but one term, which is A1 plus n minus 2 times D plus A1 plus n minus 1 times D. Why n minus 2? Because it's the last but one term, so it's n minus 2 times D. The last term is A plus n minus 1 times D. According to this formula, it's the nth term. I can also rewrite this particular summation in the reverse order. So I simply put this term in the beginning. I say A1 plus n minus 1 times D here, plus A1 plus n minus 2 times D here, and so on up to A1 plus D plus A1. So you see this A1 comes in the end and this term in the end comes in the beginning. So I've just reversed this. It's the same set of terms. This is also Sn. The first line is also Sn. So when we add both, we get 2 times Sn is 2 times A1 plus n minus 1 times D. So I add this A1 plus this A1. So it's 2A1 plus this term n minus 1 times D. If you look at it carefully, if I add this term and the second term of the first row and the second term of the next row, we again get the same 2 times A1 plus this D here, and we have a minus 2D here. D minus 2D is minus D, and ND. So ND minus D is nothing but n minus 1 times D. So if you look at it, the same term that repeats here, that keeps repeating for as many terms are there in the series. So if I have 5 terms, I will get 5 times this particular formula or the term. So from this, what happens is Sn, or the sum, becomes this whole term, which is nothing but 2A1 plus n minus 1 times D, n times, because if there are n terms, we know it's n times, divided by 2. This 2 comes over to the other side as divided by 2, and this can be simplified to n by 2 times A1 plus AN. Why AN? Because we know here that the nth term at the top we saw is A1 plus n minus 1 into D. So I take one A1 out of this and write it here, and the other A1 goes along with n minus 1 into D to become AN. So the sum of n terms of a finite arithmetic series is given by n by 2 times a1 plus an, which a1 is the first term and a1 is the nth term of the series, and n is the number of terms in the finite series.